So in this next video, we're going to talk about the ideal gas law. So we've done gas laws that include variables like pressure and volume and temperature, but remember there's a fourth variable that can affect gas behavior, and that's moles. So if you have a problem that involves moles, we need to use an ideal gas law. There's two of them. The ideal gas law number one is P times V equals N times R times T. So P, of course, is pressure, V is volume, T is temperature, and that's in Kelvin. N is amount of moles, you may remember that, and R is something new. R is called the ideal gas constant. It's a known number, it's a value that they have to give you, and it's got some crazy derived units at the end of it. The ideal gas constant is 8.31 liters times kilopascals divided by moles per Kelvin. So this number will change if we are not using kilopascals. If you're using atmospheres instead, this number in front will change. But this shouldn't bother you. This shouldn't be a big deal. This number will always be supplied to you in any test question I may give you. You just need to plug it in and use it correctly. So here's an example. A sample of argon gas at STP occupies 56.2 liters. Determine the number of moles of argon and the mass in the sample. So when you get to this part of the question, it says determine the number of moles. You should know that none of the gas laws we've learned are going to help you solve this. They only solve for pressure, temperature, or volume. If you see moles in a problem or they're asking you to solve for moles, it's most likely an ideal gas law question. So we will start with the formula PV equals nRT, and it says that we are at STP, a sample of gas at STP. That's why my pressure is 101.3 kilopascals. That's my standard pressure. And the volume is 56.2. It says so right here. This gas occupies 56.2 liters. Liters is a unit of volume. They want us to solve for moles, so that's what we're going to leave blank here. We'll plug in the ideal gas constant, or R, next. You can see in the bottom that's given to us. It's 8.31, and then all of those units. And lastly, we are going to multiply by the temperature, and they say that we are at standard temperature. So standard temperature is 0 degrees Celsius, or 273 Kelvin. So next we want to isolate the variable, so we're going to divide both sides by the ideal gas constant times 273 Kelvin. On the right, we'll see that that will cancel off and leave us with N. On the left, I'm going to show you how all the units cancel off. So I'm a big proponent of always writing units so you can cancel off above and below. When I get to ideal gas laws, I tend to get a little lazy because this is really annoying to write these units every time. But I want to show you how why they are what they are so that this math will give us N, or moles. So remember, if the same unit is above and below, it will cancel off. So I have liters and liters above and below a line, so they'll cancel. Kilopascals and kilopascals will cancel. Now down here under this line, this is technically below this. So Kelvin and Kelvin cross off, and that's why I'm left with moles, which is what I'm solving for. So if I punch this in my calculator correctly, I'll get the right answer. So in my calculator, I would do 101.3 times 56.2, enter, divided by, open bracket, 8.31 times 273, close bracket, enter. And if you do that correctly, you will get 2.51 moles. So our next ideal gas law is really the same gas law, just written in a different way. We call it ideal gas law number 2. So we have PV equals lowercase m RT divided by capital M. So M is mass in grams of your sample, and capital M is molar mass. So it's used for similar but different problems. So this question says determine the volume of determine the volume occupied by 2.34 grams of carbon dioxide gas at STP. So if they're asking for grams, or they give you grams, or they give you a specific gas like carbon dioxide that you could find the molar mass for, it should tell you to do ideal gas law number 2. So here's ideal gas law number 2. The pressure would be our standard pressure because we are at standard temperature and pressure. So 101.3 kilopascals. They want us to determine the volume, so we're solving for V. So the mass they gave us is 2.31 grams. R is the ideal gas constant, the 8.31. Now this time I'm not going to write the units, but feel free to if you'd like. We're going to multiply that by the temperature. We see that the temperature is the standard temperature, which is 273 Kelvin. And we're going to divide that by the molar mass of carbon dioxide. So hopefully you remember carbon dioxide is CO2, so that contains the mass of 1 carbon, which weighs 12 grams according to our periodic table, and 2 oxygens, which each weigh about 16. So 16 times 2 is 32 grams. So 32 plus 12 is 44 grams total for the molar mass of carbon dioxide per mole. So we'll plug that in here, and now we need to cross multiply. So we're going to go volume times 101.3 times 44. Okay, so that's my cross multiplying this way is equal to all of this. So 2.34 times 8.31 times 273. I'm going to divide both sides by 101.3 times 44 to isolate the variable. On the left, it will cancel. And on the right, those units will cancel to give me 1.2 liters. So in summary here, use ideal gas law number 1 when the problem is asking you for moles or gives you a mole amount. Use ideal gas law number 2 when the problem is asking you to solve for or gives you mass of a specific gaseous chemical. You don't need to memorize the ideal gas constant because that will always be given to you. And that's how you do ideal gas law problems.